This video demonstrates how to find the 4 critical points when graphing a quadratic that has 2 rational zeros. We'll use factor by grouping to find the zeros. The 4 critical points are the y-intercept, the vertex xy, x-intercept number 1, and x-intercept number 2. The y-intercept is given to us in the equation because we're in standard form, ax squared plus bx plus c. Our function is 6x squared minus 11x minus 10. So our y-intercept is 10. Now we need to find our vertex. The formula for the formula for the x-coordinate of the vertex is negative b over 2a. And in this case, it's negative 11 divided by 2 times 6. So that gives us a negative 11 divided by 12 is 11 over 12. It's almost 1, almost positive 1. So that tells us that our vertex is going to be right, very close to 1, just to the left of 1. So that's our axis of symmetry for this parabola. Now we need to find the y-coordinate of the vertex. How far down does it go? Where is the lowest point of this parabola? You find that by substituting the x-coordinate of the vertex into the original function to find y. F of 11 over 12 gives us 6 times 11 over 12 squared minus 11 times 11 over 12 minus 10. Squaring this, we get 6 times 121 over 144 minus 121 over 12 minus 10. We factor 6 out of 144. That gives us 24. 121 over 24. This has to have a common denominator so that we can add all these terms. This has to have 24 in its denominator. Multiplying by 2, you get 242 over 24. This term also has to have a denominator of 24. 24 times 10 is 240. So here we maintain the same value. We've just changed each term to have a denominator of 24. 121 plus negative 242 gives us a negative 121 over 24 minus 240 over 24. That gives us negative 361 over 24. That's the x-coordinate of our vertex. That's almost 15, just about 15. We need to write the vertex x and y coordinates as an ordered pair. So we'll have 11 over 12 is the x-coordinate of that vertex, and negative 361 over 24 is the y-coordinate of that vertex. So now let's plot that point on our coordinate plane. We have our axis of symmetry, the x-coordinate of the vertex. For all values of y, this is x, 11 over 12. Negative 361 over 24 is about negative 15. So there's our vertex, right about there. We have the y-intercept, negative 10. We'll plot that right now. And now we just have to find the roots. We'll use factor by grouping. For this equation, a times c is 6 times negative 10 gives us negative 60. B is negative 11. So we're looking for the 2 factors of 60 that multiply to give you negative 60 and add to give you negative 11. So we'll go 1 is 60, 2 times 30 is 60, 3 times 20 is 60, 4 times 15 is 60, And there we can get a combination of negative 15 and positive 4 to give us negative 11, which is that middle term, our linear term. So now we can rewrite our linear term using these two values, negative 15 and 4. So we have 6x squared minus 15x plus 4x minus 10. And now we can factor by grouping. Put parentheses around these two terms and these two terms, and it'll factor very nicely. Here we'll factor out a 3x. And leaving the binomial 2x minus 5. So 3x times 2x minus 5 plus, and here we'll factor out a 2. Should have been 2x left in the parentheses. Okay, so now we have a common factor between both of these terms, 2x minus 5, 2x minus 5. And then we have 3x plus 2 as the other binomial. Now in order to find the roots, we find the value of x that sets each of those binomials to 0. Subtract 2 from both sides, we get 3x is equal to 2, x is equal to 2/3. That's one of the roots for zeros. Here, we have 2x minus 5, set that to 0, add 5 to both sides, 2x is equal to 5, x is equal to 5 over 2. Sorry. X is equal to 5 over 2, or 2.5. So now we plot those 2 points on this coordinate plane, we can sketch our parabola. X is equal to, this should be negative 2/3. X is equal to negative 2/3, which is right about there, 2/3 of the way to negative 1. And then over here we have 5.5, 5 over 2, that's 2.5. It's right about there on our coordinate plane. And you can see that that should be the same distance from the vertex, or the axis of symmetry, to both of our x-intercepts. Should be symmetrical. Now we'll just sketch our parabola. It'll take this shape. The other way to find the roots is to use the quadratic formula, which is not shown in this video. That concludes this video.